So we were calculating the pH of the solution. We had to calculate the pH, so we had calculated all these other volumes that was so much, not just skip steps. Let me just go back to this one, just in case somebody doesn't understand how I got it. Remember when they told us sulfuric acid ionizes completely? Remember it is H2SO4, so there's 2 of these H's, so the concentration here we have to multiply by 2, and then let me show you how I got that. So if we have 1.18 times 10 to the exponent -2, taking that down, multiply that by 2, and then that is then how I got that. If you didn't know how I got that answer there for the concentration, which is 0.0236. Remember, we are not done. Let me just write mole per cubic decimeter here. We are not done. They wanted us to calculate the pH. So now I'm going to move to calculating the pH. So when we calculate the pH of any solution, we say pH is equal to -log, and the concentration of the H3O plus ions in solution. I just want to deviate from this one, just in case they asked you to calculate the pH, but they had given you sodium hydroxide, which is NaOH. It means you had to do another calculation. And this is where most of you guys make the mistake. When you talk about OH ions and H3O plus ions, it is not the same thing. So you have to work vice versa. Just going to branch it off a little bit. Remember, we have H3O plus and we have OH minus is all equal to 1 times 10 to the -14. So if you were given this one of the base, you first had to solve for this one, and then you can then put it in here. But in this case, we were given the acid, so I'm just going to go straight into it. I'm going to say -log, and then I'm going to put in the concentration that I got, which is 0.0236. And then let's see what we get here. Let me just move it to this side. So I'm going to get log, -log, bracket 0.0236, close my black bracket. See what I get? I get 1.6. I must leave it into 2 decimal places. The 7 will change the 2 into a 3 because we have to round it off to the nearest whole number, and I get 1.63. I just again want to elaborate on this. If we have a pH scale, let's say here we've got 0, neutral is 7, and this is 14. My scale is not drawn, my graph is not drawn to scale. Anything closest to 0 makes it very acidic and very dangerous. Closest to 40 makes it very basic. So now if you had to calculate the pH of H2SO4, which is sulfuric acid, and they told us sulfuric acid is a strong acid, they even asked us why. If you were to get an answer that is something in the more basic side, your whole answer is incorrect. So we have to prove that pH of an acid is closest to 0. So I can see 1 point something should be around there. Very close to 0 means very, very acidic. So we are correct by finding 1.63 because that shows it is an acid. Anything above 7 would have been incorrect. So that is that question done. Let's just double check. Yes, we've got all the questions there. Let us tackle another one. Also question 4, also acids and bases. And as I say, if you start preparing for your exams and stuff like that, you'll see that there's a common trend that they use. Sulfuric acid is one of the ones that they know. So you're going to know and understand the properties of sulfuric acid off by heart. You're going to see that they like to use the same types of bases, the same types of acids and so forth. And the questions are more or less the same. It just depends in what angle the examiner brings it. So let's look at this one. 7.1 says sulfuric acid is diprotic. Now we know that there are certain terminologies that we use, right? And now it says define an acid in terms of the Lowry-Brownstedt theory. Just to look at sulfuric acid again, if you had forgotten how it looks, we've got H2SO4. Now they want us to define an acid according to the Lowry-Brownstedt theory. I just want to go back to this question. In this question, they asked us, oopsie daisy, to define an acid according to Arrhenius's theory. So which shows you that you need to know both. They don't always ask both, but you need to know both. So let's answer this question. So this is number 7.1.1. So we need to define it according to Lowry-Brownstedt, and he says an acid is a proton donor. Ooh, can't spell proton. Janet will kill me. Is a proton, which is H plus, is an H plus ion donor. So we know that it's going to lose the one. So let's go to the next question. Let's see what that one says. So now it says, give a reason why sulfuric acid is referred to as a diprotic acid. Now, this already gives it away. The word di means two. So if you guys can remember in grade 11, we always talked about mono, which means one, di is two, tri is three, tetra is four, and so forth. And always remember, in chemistry, we always have our own way of naming, especially if you look at organic chemistry. So some of these words actually give it away. We have di. We know that sulfuric acid has got two H's because it ionizes completely. In the previous question, we had to multiply the concentration by 2 because it will then lose the two hydrogens. So let us explain it because this is what the examiner is looking for. So this is why it is called diprotic. It ionizes. Please do not write slang language. Ionizes to form two protons, or 2 moles of H plus. Or we can then say it donates. It donates 2 H plus ions per H2SO4. Minus molecules. So it does give away 2. That is why it's H2SO4. Let me just move to 7.2. We're going to have 7.2.2 now. Let's work that one out. So now 7.2 says the hydrogen carbonate ion can act as both an acid and a base. Now, water can actually also act as an acid and a base. And Tops, where do you know this from? When we do conjugate acid-base pairs, it reacts with water according to the following balanced equation. Now, when something can act as an acid and a base, it actually gives it a name. Let's look at what's happening here. So I've got HCO3, and then I can see all of a sudden it's an H2 here, and then I've got water and then an OH minus on that side. So something gave away and something accepted. Let's look at 7.2.1. We must write down one word for the underlined phase. Underlined phase can act as an acid and a base. So this is how I always tell my kids to remember something like this. Remember when you were young and they always used to tell you frogs can live in the water and they can also live on land. And what do we call it? We call them amphibians. It can live in the water and it can live on land. Amphibians. Now, if we have something that can act as an acid and as a base, meaning that it can donate an H plus or accept an H plus in the reverse reaction, we then call it an amphrolite. Amphibian, amphrolite, amphibian, amphrolite. So make sure that you actually get the terminologies. But like I always say, if you forget or if you want to actually link some chemistry into your everyday life, there is a way you can actually remember it. Like now, amphibians and amphrolite. So the underlined word, why or what do we call substances that can act as an acid and a base, is an amphrolite. Some people actually even use amphotic. Amphotic. So you can use this one. I use mostly this one in my classroom. So this is 7.1. Let me just number that correctly. 7.1. Now let's go to 7.2.2. Let's look at it here. It says HCO3 acts as a base in the above reaction. Write down the formula of the conjugate acid of HCO3. Now, I know we don't have a lot of space here, but I'm going to show you guys what is happening. So here I've got HCO3, and then all of a sudden it's H2CO3. This means that the water dissociated into H plus and OH minus. The water is donating an H, and this one is accepting it. Anything that donates means that it is an acid. What accepts is a base. And then we can see it becomes H2CO3. If we were to read it in the reverse, this means this will dissociate into H plus and HCO3 minus. Now, this one is donating an H, acting as an acid, but in this case, it accepted acting as a base. So that's why it's called the conjugate acid-base pairs. And now they want us to find the conjugate acid of HCO3, which is H2CO3, and that is the conjugate that we're looking for. Remember, every time we're doing conjugate acid-base pairs, you must first read it forward and see which one accepted and which one donate. Whatever donates an H plus is an acid, the one that receives is a base. And then again, you do the same going in this direction. This one will accept an H from this one. Anything that accepts is a base. Anything that donates is then the acid. So let's just write down what the examiner would have wanted us to write down. So the conjugate acid-base pair is H2CO3. So let's look at 7.3.1. I think it's a calculation. These are very long questions, my darling, so make sure that you pace yourself really well in the exam. So now we have a learner accidentally spills some sulfuric acid. We know it is an acid, which is H2SO4. It has a concentration of that. So I'm going to go back to my diagrams and I'm going to draw myself a picture. We have some sulfuric acid, which spilled somewhere. We know that they're telling us it has a concentration of 6 moles per cubic decimeter. Let's read what else they're telling us. After this learner has spilled the sulfuric acid with that concentration from a flask on the laboratory bench, her teacher tells her to neutralize the spilled acid by sprinkling sodium hydroxide. Sodium hydroxide is a base. Now, if you can remember, in the previous question, they used H2SO4 and sodium hydroxide, and we are using it exactly the same way here. But now it's in carbonate powder, onto it, sodium hydroxide carbonate powder, onto it, and the reaction that takes place is here. So we must assume that H2SO4 ionizes completely. Remember, strong acids will ionize completely. So this is the reaction that we have. Something very important and crucial to remember is your mole ratio. This is 1:2. They're giving us more information. They're telling us that the fizzing due to the formation of carbon dioxide. Now remember, if anything bonds or comes into a reaction with CO3, I get 3 things instead of 2. I'm going to get my salt, my water, and carbon dioxide. So that's the carbon dioxide that is fizzing. It stops after the learner adds 27 grams of sodium hydrogen carbonate to the spilt acid. So we have the concentration of my acid. Now we have the moles or the grams of the sodium hydrogen carbonate. I just want to put it here. So let me look here. That's my sulfuric acid that was spilt. And then they're telling me that I'm going to add, we are adding, let me see how much we're adding again. So of that one, we're adding 27 grams. Well, we're going to add 27 grams of that powder stuff. Now let's see what the question asks us. That's a picture I need to have in my head already. They want us to calculate the volume. They're looking for the volume. We have the concentration, volume of sulfuric acid that spilled, and assume that the sodium hydrogen carbonate reacts with the acid. They want the volume of the sulfuric acid. They didn't tell us how much it was, but one thing they told us is that it ionizes completely, and they're only telling us the grams of the sodium hydrogen carbonate. So now let's see how we are going to do this one. So now remember, I'm just going to write it here. If I have my H2SO4, I am given the concentration, which is 6 moles per cubic decimeter. I know that my moles is 1. I do not have the volume. Then I have NaHCO3. They told me they are sprinkling it over the spilled sulfuric acid. They've given me the mass of it, which is 27 grams. Remember, my darlings, there's a big difference between a small m and a big M. This is grams, big M is grams per mole. They've given me the grams, and I know that looking at my equation, my moles are going to be 2. So first things first, that I know is that I've got one unknown and then my mole ratios, but I've got more information moving here forward. right? Because remember, they're telling me this ionized completely with that. If I can then find information here, I then can know how many moles of this reacted with my sulfuric acid because I have the grams. Now, using my periodic table, I can then say the moles of NaHCO3. Now I'm going to find my moles on the periodic table. Looking on the periodic table, for sodium we have 23 grams per mole, hydrogen is 1, carbon is 12, plus 3 oxygens, which are 16. Looking at this, I'm going to have 84 grams per mole. Now I can say that the moles of the grams is M over big M. I can therefore say they gave me 27 grams, and this is 84. So let's see how much we're going to get here. Put it as a fraction. I'm going to have 27 all over 84. I've got 0.32 to 2 decimal places. The 1 will not change the 2. So I've got 0.32 moles. Now that I've got the moles of 27 grams that reacted while sprinkling it on the sulfuric acid, I can therefore say if sulfuric acid is H2SO4, it is a mole of 1, and this is 2 moles of NaHCO3. If this is 0.32 for 2 moles, I need to find 1 mole of that, meaning I'm going to divide it. Half of 32 will give me 16, which is 0.16. And then you have to go down with it. And then it is a long question, my darlings, but if you can use the same steps as how I used in the previous question, then you will then be able to find the volume of the sulfuric acid that actually spilled. But this is how you need to start thinking about doing your acids and bases. Remember, always draw yourself a picture. Thank you so much for joining me in this show. I will see you next week when we do another topic. Make sure you bring through those questions. Ciao.